An empty balloon has a mass of 12 grams. The balloon is filled with helium, which has a density of 179 thousandths kilograms per cubic meter. The filled balloon has a radius of 23 hundredths meters. What is the buoyant force acting on the balloon? Hint, the density of air is 1.29 kilograms per cubic meter. What is the total gravitational force in the balloon? What is the net force acting on the balloon? Okay, I'm going to go ahead and start this by drawing ourselves a picture. So I've got a balloon. Okay, and we know some things about this balloon. The first thing that we know is there are a couple of forces acting on the balloon. Okay, there is the gravitational force acting downward, and there is a buoyant force from the air acting upwards. We also know that the balloon has a mass of 12 grams. And I'm going to go ahead and convert that immediately to kilograms. So 1,200 or 12 thousandths of a kilogram. And we know that the radius of the balloon is 0.23 meters or 23 centimeters. And we also know that the helium has a density of 0.179 kilograms per cubic meter. Okay, so we have a lot of things written down here, okay? So let's see what we can do. Well, part A. What is the buoyant force acting on the balloon? Buoyant force. The buoyant force is equal to the mass of the displaced fluid times the gravitational field constant. Well, gravitational field constant, simple, 9.81 newtons per kilogram. Mass of the displaced fluid, that is not this. This is the mass of the balloon. The balloon is not a fluid. We need the mass of the displaced fluid. When I filled this balloon up with helium, what got pushed out of the way? What was surrounding it? That's air. So in this case, we need the mass of the air that was displaced. And that is not given to us here. We need to find it. Okay, so how are we going to find the mass of the air? Well, one of the things that they're telling us as a hint is the density of air is 1.29 kilograms per cubic meter. Okay, so the density of air is equal to 1.29 kilograms per cubic meter. That's helpful, okay? Why? Because we can relate volume, mass, when we have density, okay? The density of air is going to be equal to the mass of the air divided by the volume of the air, okay? So we know the density, 1.29 kilograms per cubic meter. We want to find the mass. We need to know the volume of the air. Okay, well, how much air got pushed out of the way when we blew up this balloon? Well, however much space the balloon takes up, because air is completely surrounding it. The balloon is submerged in the air, okay? So we need to find the volume of this balloon. Well, volume, we're going to approximate this to be a sphere, and the volume of a sphere is 4/3 pi r cubed. So substitute in our radius of 23 centimeters or 0.23 cubic meters, and we're going to get a volume of 0.05096 cubic meters. Substitute that in here. Multiply both sides, and we get the mass of the air to be approximately 0.0657 kilograms. Substitute that in here. The buoyant force is equal to 0.0657 times 9.81 newtons per kilogram. We get a buoyant force of 645 thousandths of a newton. And the buoyant force is going up. So we can draw a little arrow. We can just leave it positive because positive is our up direction. Okay? So we've answered part A. A lot of work to get there, but we've done it. So let's look at part B. What is the gravitational force of the balloon? Well, gravitational force is equal to mass times gravity. Got to think here a little bit though, okay? The mass of this balloon is not just 12 grams anymore. Okay, we filled it with helium. So we have to include the mass of the helium because we need the total mass of everything that's inside here now. So I need to have the mass of the helium plus the mass of the balloon, so I get the total mass of the balloon when it's filled, and multiply that by 9.81 newtons per kilogram. Mass of the balloon, simple. We've got that. 12 grams, or 0.012 kilograms. Gravitational field constant, still 9.81 newtons per kilogram. What we are missing is the mass of helium. Once again, we can use density to relate mass and volume, okay? The density of helium is equal to the mass of the helium divided by the volume of the helium. Density of helium was given to us, as 0.179 kilograms per cubic meter. We don't know the mass of the helium. The volume of the helium, well, I filled this balloon completely up with helium. Okay? So whatever the volume of the balloon is, that's how much helium I put inside. Okay? So we've got that already, 0.05096. Solve this, and we get the mass of the helium is 0.00912 kilograms. And you might be thinking to yourself, that's pretty small. Well, this is 9.12 grams. This is 12 grams. They're very close, okay? We cannot ignore the helium. It is not negligible. Okay? Substitute everything in there, solve, and we get the gravitational force as 0.207 newtons, and that is downward, okay? And now we are ready for part C. Part C asks, what is the net force acting on the balloon? Well, the net force is when you add up all the forces. So we've got our gravitational force acting downward, so negative, plus our buoyant force acting upward, so positive. So the net force is equal to negative 0.207 plus 0.645, and we get the net force is equal to 0.438 newtons, and the 645 was greater, that was upward, so this is an upward force. This tells us that the balloon is going to rise.